Every morning when I wake up, I have a routine. Granted, I don't always keep it, but it goes something like this. Most of the time, I'll turn right on my street. There's no particular reason I do, I just do. Now, I'm sure you've heard of the concept of parallel universes or multiple realities, however you heard it. Where, for example, instead of turning right in the morning, me in some other universe has the same routine as I do, but turns left instead. And me in a different universe may not even get up that early. This idea of parallel universes is what the vast majority of people think of when they hear the concept of the multiverse. But the theory of the multiverse actually goes way beyond decisions individuals make in each universe, all the way to the nature of each universe. The theory of the multiverse predicts a cluster of multiple universes, each with possible varying physical laws and constants. Now, the concept of varying physical constants originates from the understanding of the physics of the small, commonly known as quantum physics, as well as the origins of the universe. The behavior of particles and waves at a quantum level is known to be very random, unlike how we're able to use classical physical methods to predict the behavior of nature. The theory of the Big Bang predicts that the universe began from an infinitely small size and exploded to what we have now. At the infinitely small size, some proponents of the multiverse theory predict that the random behavior of particles could have spawned into existence other universes that have different physical constants than ours.
When you take quantum mechanics and apply it to aspects of the fabric of space on that scale, what you have is a gurgling of the fabric of space-time. This gurgling is because quantum mechanics prevents you from knowing anything with precision about the system. So you can't say, here's a spot on that grid. That spot is this undulating, pulsing foam. And so now when you look at this foam, applying the laws of quantum mechanics to it, you realize that this fabric is not limited to one zone or another. In fact, there's a region of the fabric that could hatch out an entire universe with the variations in the laws of physics simply because the conditions that would spawn the laws of physics had variation in them.
Take the amount of dark energy, for example. Now, if you're not entirely sure of what dark energy is, don't worry, most physicists are not too sure either. It is basically classified as a dark mist in space that creates repulsive gravitational force acting upon several galaxies out there. According to the multiverse theory, the density of dark matter will vary in each universe. And so in one universe, you can have this amount of dark energy, another this, the other this, and so on. The amount of dark energy in each universe will create very special circumstances and even cause some of these universes to not exist.
Why do we humans find ourselves in a universe with the particular amount of dark energy we've measured instead of any of the other possibilities that are out there? Those universes that have much more dark energy than ours. Whenever matter tries to clump into galaxies, the repulsive push of the dark energy is so strong that it blows the clump apart and galaxies don't form. And in those universes that have much less dark energy, well, they collapse back on themselves so quickly that again, galaxies don't form. And without galaxies, there are no stars, no planets, and no chance for our form of life to exist in those other universes. So we find ourselves in a universe with the particular amount of dark energy we've measured simply because our universe has conditions hospitable to our form of life.
Some scientists often put off the idea of a cluster of universes coming together to form a multiverse and claim it's merely philosophical. But renowned astrophysicist Neil deGrasse Tyson, like other brilliant physicists, make very convincing arguments for its possibility. Now, arguments alone are not enough, especially in the scientific world. It requires testing, which is one failing point of this particular theory. It is almost impossible to test. The Perimeter Institute of Theoretical Physics have come up with some interesting ways of testing this.
And the idea is that somewhere in that mess of bubbles, you'll find a bubble that contains our universe. If we run into another pocket then that would actually show up as a fairly dramatic bruise in the CMB. If I were to look at this light in different directions, then I would see some disk in the sky where the intensity of the light is a little bit different. If you wanted to go out and test this idea, then one way to do that is to go look for these bruises in this light from the early universe.
If you found this video helpful, smack the like button and subscribe if you haven't already. Thank you for watching, and I'll see you in the next.